So what we're going to be working with today is we're going to continue working with similar figures, right? So the other day we started analyzing what similar figures were, how we were able to tell whether they were similar or not, right? And so when looking at similar figures, we knew that they were alike, right? Similar figures, they're the same shape, the angles are all congruent, the sides are all proportional to one another, but the sizes are always going to be different, right? So the difference between congruent and similar is, again, congruent is everything is exactly the same, and similar means that they're going to be alike to another, right? So what we're going to continue with is we're going to continue working with similar, but now we're going to start analyzing different ways to be able to tell whether triangles are similar or not, right? So again, this is only going to apply to triangles, and we've worked with something similar to this before in the past too, because we've worked with the 5 congruence postulates, which were 5 different ways to tell that triangles were congruent. So 5 ways that we learned for triangle congruence was SSS, SAS, HL, AAS, and ASA, right? When it comes to figuring out whether triangles are similar, it's not all 5 of those ways, but there are 3 different ways to tell that triangles are similar or not. And those 3 ways are going to be AA, SSS, and SAS, right? And that's it. There's only 3 ways to tell if triangles are similar or not, and we're going to go over all of them. And again, just practice and knowing what this all looks like. You guys have a pretty fair idea of what this is. AA would stand for angle, angle. SSS stands for side, side, side. SAS stands for side, angle, side, right? And we're going to go over all of them, and then I want to show you guys how they're all used practically, right? So let's start with the most obvious one to see, which is AA, right? Angle, angle. AA similarity. And so when we're dealing with AA similarity, angle, angle, right? That's what the 2A stand for, an angle and an angle. They need to give us 2 angles, right? So let's say we have 2 triangles, and keep in mind, this is not to show that the triangles are congruent, right? It's to show that the triangles are similar, that they're alike. Because again, whenever you see the word similar, it means alike. In order to know whether triangles are similar or not by AA, all we need is exactly what it says. We need 2 different pairs of angles, right? And remember, whenever you see AA, it doesn't mean we just need 2 angles in general. We need 2 pairs of angles. And what we learned about similar figures is the angles need to be congruent. So the way that AA would look would be, let's say for example, if this is 40 degrees, let's say that that's 40 degrees. Let's say I had that, right? This angle here is 40, that angle there is 40. That would not represent 2 angles. That would represent 1 pair, right? And then let's say that this here is, let's say that that's 70, right? Let's say that this one up here is 70. If we have that, the way that we see this, and we label it exactly the way we've always done it in the past, we see that these 2 angles are congruent, so that would be an angle, right? We see that the 70 and the 70 are congruent, so that's an angle. And automatically, since we have an angle and an angle, we have 2 angles, we know that these 2 triangles are similar. They're similar by AA. And the reason why we only need 2 angles, right? The second that 2 angles are congruent in a triangle, automatically these 2 triangles are similar. And the reason we know that is for one fact. Even though this triangle is bigger than the other, there's no denying that, we always know a triangle, whether it's big or small, it's always going to add up to 180, right? So if we look at that, if these 2 add up to the same amount as those 2, automatically this is equal to that. And we can see that because if 40 plus 70, 70 plus 40 is 110, 180 minus 110 would make this 70, right? Same thing there, that's 70. 40 plus 70 is 110, so that's 70. So when we have 2 angles, automatically the third one's always the same. So that's why we only need 2 and we don't need 3 angles. Because if 2 angles are the same, automatically the third one's also the same, it's congruent. So that's how AA shows that it's similar, because as long as the angles are congruent, the triangles are going to be similar. So again, when it comes to AA, just always remember, all we need is 2 different pairs of congruent angles, right? That would be 1, that would be 2. So that would be AA. Now we're going to go on to SSS, and the good thing about SSS, you've actually done it already last lesson. It's just going to look a little differently in terms of the way that you're reading it now, right? So SSS, similarity, literally stands for side, side, side similarity, right? stands for side, 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 which means that we need 3 sides, right? And so with that, again, we're not saying that the sides are going to be congruent. We're saying that the sides are all going to be proportional, right? Which means they're changing the same way. It's getting 2 times bigger, 3 times bigger, 4 times bigger. You can get 2 times smaller, 3 times smaller, 4 times smaller. The relationship between them is always the same, right? So if we're looking at this, let's say, and let's say that this side here, let's make this 4, let's make this 3, let's make that 5, right? Now let's make this 10, let's make this 8, let's make that 6. In order for this to be similar by SSS, again, 3 sides, we're not trying to show that the sides are congruent. We're trying to show that the sides are proportional. So in order to show that, what we have to do is we actually have to calculate scale factors, right? The way you always find scale factors is you join up the numbers that correspond to each other. So for example, we know that, let's start with the easiest. We know that we're going to join the 10 with the 5. And the reason that we're actually combining those two together, we're actually joining those two together, is because the biggest side of this triangle is 10, the biggest side of this triangle is 5, so we join those two together, right? And whenever you find scale factors, it's always division, right? So 10 divided by 5, we know it gives us 2, right? So there's our scale factor right there, is 2. Now, let's look at the 6, right? We know that the 6 is the smallest side there. So if 6 is the smallest side there, we want to put it with the smallest side here. Smallest with the smallest, right? So we're going to do 6 divided by 3 equals 2, right? And now what we're going to do, the other sides that go together. We have the 8 with the 4, right? Because again, they're the middle sides in each triangle. So 8 divided by 4 gives us 2, right? And what we notice is all 3 scale factors are the same. If all 3 scale factors are the same, automatically we know that it's similar by SSS. And that's all it is, guys. Again, it's something that you guys did last week when you were just calculating whether figures were similar or not. But when you're actually trying to figure out whether it's similar by SSS, we're just trying to see if all the scale factors are the same. If all the scale factors are the same, all 3 scale factors, it's similar by SSS, because each scale factor represents a side. That's a pair of sides, that's a pair of sides, and that's a pair of sides. So all 3 scale factors are the same, similar by SSS. And don't just assume because they give you 3 sides in each triangle that it's SSS. It's not. All 3 scale factors have to be the same to be SSS, all right? So again, we have that. And then the last one is SAS, right? SAS, again, what you guys know, is going to be side, angle, side. And it's the same idea, it's just now the parts that we have to make sure that we have right? So for it to be SAS, similar, we know that we're going to need 2 pairs of sides and the angle, right? And it's not just important that the angle is just there anywhere. The angle needs to be between the sides. Just like when we were working with SAS congruence, the angle needed to be between the sides. Same idea here. The angle needs to be included between the sides. So if we're trying to show this again, right, SAS, okay, we have 2 triangles. Again, one could be bigger, one could be smaller, because we're not saying that they're congruent. We're saying that they're similar, that they're alike, right? Let's say that I give you that this is 9. Let's say that this here is 6. Let's say that that's 3. Let's say that that's 2. And now, remember, I'm going to put the angle here. Let's say that that's 30 degrees. Let's say that that's 30 degrees, right? So, first thing that we know, and we can also go part by part, we know that we have an angle, right? So that's an angle right there, because they're both congruent, the angles. And now let's look, because we have an angle, right? We also see that the angle is between the sides, but in order for it to be SAS, it needs to have the same scale factors, right? So the way we're going to do this again, we know that the biggest side of this triangle is 9. We know that the biggest side of this triangle is 3. So we're going to divide those 2 together, okay? 9 divided by 3 gives us 3, right? Now we know that the smallest side here is 6. Smallest side here is 2, right? So we're going to do 6 divided by 2, which gives us 3. And what we know is these two scale factors are the same, right? So we have two sides that are proportional, right? Those two. We have two scale factors that are the same, and the angle that's between the sides. So the second that you have two scale factors that are the same, and the angle lies in between them, we know that we have SAS. Similar by SAS, right? Similar by SAS. And it's just for that exact reason, guys. We have two pairs of sides that are proportional, right? We have the two scale factors that are congruent, and the angle that's between the sides, right? It's between the sides. So just always keep that in mind. SAS means you're going to have two scale factors that are congruent, and you're going to have the angle that's between. So those are the three ways, again, AA, SSS, and SAS. Now let me just show you 3 examples, just so you guys can actually see how this is used and all that, just so you guys feel comfortable seeing it, okay? So I'm going to give you 2 triangles, and I'm going to ask you whether those 2 triangles are similar by AA, SSS, or SAS. I'm sorry about this. Sorry about this, guys. So the first pair of triangles I'm going to give you is going to look like this, right? I'm giving you this right here, and then I'm giving you this one right there. And then I'm going to give you this here, that there, right? So if we look at this, right? Again, I want to know if these are similar by AA, SSS, SAS, or not similar, right? So just looking at the parts that we have, we see this has 2 curves, that has 2 curves, so that represents a pair of angles, right? That has 1, that has 1, so that represents a pair of angles. Right now, automatically we know we have 2 pairs of angles, so yes, it would be similar by AA, right? Because we have our 2 pairs of angles, and automatically also we know if 2 angles are congruent to each other, we know that this last pair is going to be congruent, but that doesn't matter again. It's just knowing that fact. We know that they're similar because we have 2 pairs of angles, right? Let's try another one. And again, it's just applying it just like we applied all the other congruence postulates, guys. But now it's just dealing with similarity, right? So here, let me draw another 2 triangles. We have that right there. We have this one right there, right? So I'm going to tell you that this here is 55 degrees. I'm going to tell you that this one here is 55 degrees. This is going to be 15 and 20. And then the other 2 sides are going to be 8 and 6. Okay? We have that. And again, the triangles aren't always drawn perfectly, so don't always assume left goes with left, right goes with right. It doesn't work like that. Always know the pairs of sides that correspond to each other, right? So first and foremost, again, we have an angle, right? And more importantly, we have an angle that's between the sides. We have an angle that's between the sides, and the angles are congruent, so that's an angle. Now let's look at the sides, right? Because again, we're not saying the sides are equal. We're trying to figure out whether the scale factors are equal, right? So let's start with this. We know that the smallest side here is 6. We know that the smallest side here is 15. So we're going to put the smallest with the smallest, right? We know that 6 divided by 15 is going to end up giving us 0.4, right? We know that 6 divided by 15 is going to end up giving us 0.4. So we have, yep. And now let's look at the other one. We're going to put the biggest side here with the biggest side there, right? We know that 8's the biggest side here. We know that 8 is the biggest side there. So we're going to do 8 divided by 20, which is going to give us 0.4. And so what we notice is 0.4 right there, 0.4 right there, right? Those 2 scale factors match up. The angles between the sides. So since the scale factors are the same and the angles between, we know it's similar by SAS, right? Because we have 2 scale factors that are the same, right? The sides are proportional, and the angles between the sides. Angles between the sides. So the angles there, between the sides, and the 2 scale factors, the 2 sides are equal, are proportional, right? Let's do one more. But again, it's just getting comfortable with seeing it and getting away from the fact that the sides are congruent. Remember, guys, the sides aren't congruent. they're proportional, but the scale factors are congruent. That's what we have to make sure we look for, right? The last one now, I want to give you two triangles, right? I'm going to give you this triangle there. I'm going to give you another one here. Right? That's going to be, sorry about this, want to make sure the numbers are right. That's 32, that's 75, that's 100. On the other triangle, it's going to be 40, it's going to be 30, and it's going to be 26, right? So we know that it can't be AA because there's no angles. We know that it can't be SAS because there's no angles. So it's either got to be SSS or not similar, right? And same thing we've done. Let's match up the sides that we have, right? So let's start. So we know that we have the biggest side here is 100, right? Biggest side of this triangle is 100. Biggest side of that triangle is 100. So we're going to put those two together. 100 divided by 40 is going to end up giving us 2.5. Right? So that's one scale factor. Let's go with the middle side. We have a 75 here. We have a 30 here, right? That's the second biggest. So if we do 75 divided by 30, is going to end up giving us, same thing, 2.5, right? Now let's look. We have the smallest side here is 32. Smallest side here is 32. If we do 32 divided by 26, it gives us 1.23. And what I want you to notice is this. This scale factor is 2.5, that scale factor is 2.5, that scale factor is 1.23. Automatically, what we know, even though there's three sides here and three sides there, some people would say it's SSS, it's not SSS. In fact, it would be not similar. And the reason that it's not similar is because all three scale factors are not the same. If all three scale factors would be the same, it'd be SSS, right? But since all three scale factors are not the same, it's not similar, okay? Just always remember, guys, we have those three, SSS, SAS, and AA. Just make sure that you're not looking to see if the sides are the same, but you're trying to make sure that the scale factors are the same, okay? And any questions you guys have, feel free to always ask. Take care.